And now we're going to move on to Michael Ferris. Michael is Senior Architect, Mobile Connectivity Solutions with Colt Technology Services. And Michael's going to talk to us about the interdependence of fibre and 5G at the edge, which is a subject close to my heart. Thank you, Michael.
Well, it's a pleasure to be with you today. My name is Michael Ferris, and I've been with Colt exactly a year this week. I've had a long history in the mobile industry. I've been in it for 25 years, and I've spent the last 14 years working in backhaul and MAN connectivity. So it's my recent area of specialization. A little bit about Colt then and the team. Now, Mobile Connectivity Solutions as a team was set up at the beginning of last year. It's a very small team, and Colt is not a mobile operator, of course, although we supply services into some mobile operators. But we were set up to explore opportunities in the mobile arena that Colt might want to play in future. And it's a really interesting space for us. It's such a dynamic market. Colt, of course, sits in an evolving ecosystem. We're a big enterprise and wholesale player. And so we provide connectivity solutions for a lot of the players in the whole ecosystem. And in particular, cloud providers are a big part of our story. If we move on to a little network map, just get a bit of shape to it. We originated in London, of course, and with a big focus on Europe, but our network extends also into Asia, and we have connectivity in the US as well. We have 32 countries where we have metro networks, so where we've got our own fibre, and there's 51, I think 52 now metro areas in our network. But we also provide connectivity into cities in other countries as well. And the big numbers for us relevant to this discussion are the 900 data center connections that we have. So a lot of cloud providers there. And we provide connectivity into now more than 29,000 buildings through our own, primarily through our own on-net fibre. Now, typically in our metro areas today, we see latency that's well within half a millisecond. So, you know, there's a lot of scope for aiding the leverage of edge and 5G, which is, of course, what I'm talking about today. Now, experts say we all need more fibre. So, as the Americans say, we should eat, sleep, and breathe fibre. So that's what I did this morning. I had my Weetabix. I hope you did too. In fact, this actually came up. Joking aside, this came up as one of the images when I was searching for something for this presentation. So you have to be careful what you put in the search bar. But I was actually looking for something that shows the state of play in Europe. And this is the latest. So I'm just going to minimize something on my screen if I can. Right. So this is the latest state of play as reported by the FTTH Council for Europe. It's a very varied playing field. And it focuses on the penetration of fibre to the home or fibre to the building. And the interesting thing is that some of the biggest economies, if I highlight the 6 biggest economies in Europe, some of the biggest economies are right down the bottom of the pile. So Italy, Germany, and the United Kingdom very, very much playing catch up. And that's really because of extensive investment in copper last mile technologies over the years, which has meant that there's a lot less depth in the fibre out there in those markets. And that reflects in the availability of fibre to network cell sites as well, of course, because having a much bigger push into fibre to the home means that fibre is distributed much more widely, and it's easier to provide fibre-based cell site connectivity solutions. So these markets have really got some work to do, and of course we're seeing an improvement year on year. Let's just go back to how 4G was built and particularly focus on backhaul. So there are a number of different ways in which operators approached 4G, a lot of them had existing 3G and 2G grids to work with. And of course, microwave played a very, very big part in that. It was perfectly feasible when upgrading to 4G to upgrade existing microwave links, and you could get out of a traditional band microwave with the most modern radios, you could get all the way up to a gigabit per second. And for a typical network, if you had a focus on microwave, it was quite easy to implement, say, 50% of your sites last hop on microwave. Of course, that only gets you one hop into the network. It doesn't get you back to the core, which means that where you've got a hub that is aggregating traffic from multiple child sites on microwave, you still need some kind of aggregated backhaul solution. And those come in two different forms, really. Either you can take a direct fiber connection from a provider or a simple layer 2 service and build something yourself, or you can take an end-to-end managed backhaul service. And there are some markets where they were very successful. The UK here, where I'm based, is a case in point, where BT launched a managed backhaul service that took something like 70% of the fiber-based backhaul market for 4G. So very successful. A lot of these sites, of course, are multi-RAT, so they support 2G and 3G. In many cases, there are network shares, of course, so there could be a lot more equipment than just a 4G eNote B to worry about, but still, 1 gigabit per second was adequate for 4G. As small cells started to get rolled out, there were other slight variations to suit the small form factors needed, and they were a combination of new microwave radio systems, direct fiber, or managed solutions again. Small cells for 4G were really targeted at capacity relief to the macro layer, often using the same frequency band, so they didn't create a separate ubiquitous layer of coverage. They were really for infill and offload from the macro in particular hotspots. Of course, we mustn't forget that you also need sync distribution. In 4G, of course, it was a relatively simple affair. It's a frequency-based requirement generally, and sync E or an over-the-top PTP approach were both valid and relatively simple to implement. The point is that the currency for 4G was definitely 1 gigabit per second. Latency that you would typically have with these kind of solutions from the core would be maybe between 5 and 10 milliseconds, and the sync requirement was for frequency. Just talk about edge computing for a minute. So edge, of course, is a complement to cloud computing. It's never going to compete cost-wise if you don't have another reason for doing it. Then cloud computing is, I mean, it has taken the world by storm over the last decade, and everybody's moving to the cloud, and it's the cheapest way to build compute capability to service your applications. So what role does edge play? Of course, you have to have a specific need for edge because it's not an economic driver. So it's really about the user experience or application performance that drives a requirement for edge, or there may be reasons of data security or regulation, say data sovereignty. There may be local requirements for local processing or local data handling that start to drive things out to the edge. In Colt, we have a strategy for edge, which is twofold. So we define both the customer edge, where we put compute capability into our CPU devices that we deploy in a customer's own building. And we've got a launched universal CPU device now, and there are others in development to adapt the scale that we're able to deploy. And we've got some virtual network functions deployed on some of those devices today, things like virtual firewalls. And then we have the network edge, where we use our points of presence in a metro network, and we can deploy compute capability there, which means that we can aggregate requirements from multiple customers. And network edge is something that really can play a part in 5G. So we're on the 5G journey now. We're what, a year or so into commercial deployments, and 5G is rolling out pretty rapidly. All reports are that 5G is rolling out faster than any of the previous technologies. But what's 5G actually giving us? Well, now and in the near term, it's all about enhanced mobile broadband and a bit of fixed wireless access. And these really are not great differentiation from 4G. Okay, it's bigger, better, faster, but it's not anything new. We need to look to the mid to long term to see what the point of 5G really is. In ultra reliable low latency communications area and the massive machine type communications. And these are not here yet, but for 5G to fulfill the potential and to meet all the hype that's been created around it, we need to follow this journey, and it's going to take time. So if we look at the initial applications today, the requirements, of course, were set by the ITUR with the IMT 2020 specification, which 5G is a candidate solution for, of course. And if we look at peak data rates, then compared to 4G or IMT Advanced, we're looking at a 10 to 20-fold increase. So 10 to 20 gigabits per second is a peak data rate. But capacity density is 2 orders of magnitude greater. So 100 times the amount of traffic in a given area than 4G can handle. And that's a massive change. To achieve that, of course, we need to introduce a lot more spectrum, and that means moving into millimeter wave bands, and millimeter wave will provide much smaller coverage areas, which then means, of course, a lot more sites. And there's a lot of figures around, there's a lot of debate about it, what actually will be needed and what actually will be achieved in practice, but figures up to 12 times the number of sites are what are expected. So if we think about today's network and launching 5G at the macro level, which is what a lot of the European operators have done, then we can, of course, look at that large proportion of sites we might have on microwave and say, well, can we upgrade microwave links to support 5G? And there is a case for it, definitely. There are E-band radios up in the 70 to 80 gigahertz band that can support a 10 gig, or we call it an upgrade, but ultimately it says strip it out and put a new one in, but along the same path. That's the point. The problem, of course, is that the range of these radios is much more limited than the existing traditional bands. So the chances are that many of those links will fall out as infeasible at any kind of reasonable availability. So even just at the macro layer, we're going to see a lot of operators moving a lot more sites to fiber. It has to happen. But also 10 gigabits is just the first step. I mean, we're looking at 100 times the traffic density of 4G, which means we won't be stopping at 10 gig in this 5G journey. And we need solutions that are flexible and that we can implement a lot more capacity to each site as the demand increases, as the capabilities we deploy increase. So fiber is much more flexible for that. But also, of course, we're going to be introducing millimeter wave with small cells, because if we want a ubiquitous coverage layer at, say, 26 gigahertz, then we're going to need that large number of sites. And that means deploying small cells in high footfall areas, of course, where we've got the highest demand, but also deploying them along street canyons. And in order to enable this going forward, we really should be thinking about how do I build a fiber-based access network that I can then leverage to add small cells when the time comes. And working with partners like Colt and other fiber providers will enable the mobile network operators to build a future-proof access network. Of course, we mustn't forget synchronization. In 5G, of course, it's about time and phase, which has a lot more requirements placed on the active components in the solution, and it becomes a much more complicated solution to manage and implement. But fiber will give you the maximum flexibility. So fibre is the key for networking for high capacity density. If we move on to those later requirements, so we've got URLLC and massive machine type communications. Latency down to 1 millisecond has been talked about a lot. Well, you are not going to achieve that with the existing architecture. You are going to need to make edge deployments. For MMTC, of course, there will be local data or local processing requirements, which again points us towards edge, and coverage ubiquity in order to serve some of these IoT type applications means that we're going to need more sites. But this is sites focused on coverage rather than capacity, and with a particular focus on indoor, which I'll come back to later. If we think about the 5G core, as nicely explained in the last presentation by Ahmed, the 5G core employs a service-based architecture, which means it's cloud native and therefore lends itself to distribution among edge nodes. And just touching on reliability, ultra reliability and URLLC can make use, among other things, of fibre resilience through the implementation of rings. So again, thinking about working with your potential fibre partners to build the architecture that will best suit you for the longer term. The ecosystem, of course, is developing. 5G, as I said, is a story. If we look along the timeline, there are new standards coming out with each release, and there's more spectrum still to come in the future. Today's enhanced mobile broadband and fixed wireless access type services are by no means the be-all and end-all. The whole point of 5G is to unlock these new verticals, bring things like IoT, smart drones, smart cities, smart factories, smart ports, connected cars, remote health and robotic surgery and things like that, and mobile gaming, of course, as mentioned earlier today. And all of these things need edge. Without edge, there is a roadblock. There's not going to take us forward. The access network has evolved, of course, from 4G. In 4G in previous generations, we had backhaul and a base station that was implemented entirely at the cell site. And in the core, we have our compute capability in the core that's providing all of our services. We implemented more sites, but nothing really changed in this architecture. We introduced small cells. But it started to change when Cloud RAN was put out. Cloud RAN introduced this idea of fronthaul. It split the base station and put the baseband components into a separate function, which could then be remote. This had some success in Asia, where there was a lot of fibre available, but really in Europe, apart from a lot of experimentation, there was nothing really deployed in earnest. Where it gets interesting is in 5G, where we have this additional split. So now we have a central unit, a distributed unit, and a radio head. And this meant that some of the requirements for that fronthaul interface or the mid-haul interface between the aggregation node and the access starts to become more feasible. And now we've got some compute capability, which we can position in the aggregation point, which is our network edge. We might also, of course, as I said, be distributing part of the core. And again, this converges in the same physical type location, network edge. And for private networking, of course, we might have a network in the box where we put all of the capabilities of the network in a single platform, which would leverage our customer edge. Just want to cover off indoor before I close. Indoor is a particularly important focus for us right now. We've done some research and analysis. Now, the interesting thing is, it's unbelievable to me that with 80% of demand coming from indoor users, that there are so few indoor dedicated in-building wireless systems. Globally, enterprises have less than 5% of enterprises have dedicated in-building wireless systems, yet most of the demand is coming from there. And in the enterprise space, of course, new construction methods are really hampering the penetration of new coverage partly in 4G, but it's going to be even worse in 5G with the higher frequencies involved. And at the moment, of course, the coverage of 5G in the current bands is quite limited. So there's a lot of, there's an increasing problem with indoor. And we've also looked at what is the propensity of landlords and tenants to actually invest in building solutions. And it's quite a promising looking market. What it needs is solutions. So building landlords think that they can demand a higher rent, or that it might just be table stakes to get new tenants into their buildings, and are willing to invest. And this concept of neutral host networks is part of the solution for this requirement. And that will help us to leverage some of the new capabilities of O-RAN and vRAN, using an architecture that's been defined in the UK initially for neutral host in building using small cells. Now, JOTS is the Joint Operator Technical Specification Group. It's run by the UK MNOs. It's only UK MNO members. And they've defined an architecture for neutral hosts. I think the last document for this set has actually just been released today, funnily enough. And we've been watching this very closely. They want to bring neutral hosts into the market to take away this problem of lack of indoor coverage. So they define this architecture as a set of annexes to enable neutral hosts to start to play and to contract with them and with customers to build in-building solutions. It'll use the mobile network operator's own spectrum, so it's a bit different from the model in the US with the CBRS band. At the moment, it's a 4G play because 4G is the problem that we're trying to solve today. But of course, 5G will quickly follow, and we're trying to lay the foundations for what we will build as 5G indoor solutions going forward. And it lends itself very nicely to this network edge. And in Colt's case, of course, we can use the IQ network, our network that I discussed earlier, providing fibre connectivity to all of the venues, and also back into the operator domain for connectivity to their core networks. And in that neutral host cluster that we'll build in one of our POPs, or one or more of our POPs in each of our metro networks, we can deploy on our network edge an O-RAN and vRAN based solution. So hopefully I'm roughly on time. So just to run through the key takeaways. To meet even the basic EMBB aspirations of 5G, we're going to require very extensive fibre deployment. And I'd like to see MNOs working more closely with willing fibre partners like Colt to invest and enable 5G not just now, but for the future densification. The future potential of 5G can't be reached without edge technology. And in our case, we define edge in terms of both the customer edge and the network edge. RAN evolution and core distribution converge on the network edge, and the neutral host model that's been defined, which we hope will be extended across other European markets as well, fits very nicely with our network edge. And that's me done. Hopefully I'm on time.
You did great. Thank you very much. I remember the first time I saw that FTTH Council Europe table, I nearly fell off my chair. So a few years ago now, but it isn't what you'd expect, is it, with who's built the fibre, really?
Absolutely.
We have a question here from one of our attendees, please, Michael, who says that flexible capacity is an advantage of 5G, but how flexible can transmission networks be that rely on physical media?
Well, I mean, transmission systems, of course, ultimately you have to have some physical media. You can't get away from that. And I think flexibility comes from having the right components and the right capabilities and the right skill sets. Colt prides itself in what it's done in the enterprise space with our on-demand capabilities that we've pushed into things like SD-WAN, IPVPNs, and we've proven through those developments that we can service customers' requirements that change rapidly very quickly. And particularly this year, with what's happened with COVID and some of the very rapidly changing demands of our customers, we've been really pleased with what we've been able to do with our own SDN capabilities to rapidly respond to customers' requirements. And we have many very thrilled customers who've benefited from our on-demand capabilities. We need to see how we can work with mobile network operators to build the same capabilities that will allow them to respond quickly to changing requirements as well.
Okay, I've just got a quick question too, but it has to be quick. You talked about 0.5 millisecond latency time in 29,000 buildings because you've got fibre plumbed in.
Yeah.
And you talked a lot about offices and different models and where the edge is. What happens if nobody goes back to work in the office, Michael? We don't know right now, you know, but I mean, there's been a big shift.
There has, and I mean, well, I think we all expect that ultimately the new norm will not be quite the same as the old norm. There will be some differences, but we also anticipate that there will be a gradual return to the office. But you're right that, you know, there is going to be a much bigger component of you know, enterprise activity where people are working from home, like myself. I mean, I'm primarily a home worker even before the pandemic started. But you know, I think we've got to think about what are the applications where that's going to become relevant, and you know, does the home working aspect you know, really play a part in those applications? I mean, from our point of view, we've been looking at some of the opportunities in like smart city and smart buildings, where the latency requirements are driven by what capabilities you're trying to enable, which have local significance. If you remove the workforce and make them work remotely, then yeah, those requirements become irrelevant. So I think, yes, that it will be a different environment, but I'm not sure that that changes what drives the requirements for low latency in a particular application.
Okay. Well, Michael, thanks. That was great.